Hi everyone, I'm Sharad Guntuku. I recently joined the Penn CIS faculty in May, and I work on this broad field called behavioral data science, where I use user-generated content to understand people's well-being. The major focus is on people's health and psychology, and not sales or marketing. So this is what sort of got me into my PhD, how to make people's lives better using the data that they kind of generate. So, for example, all of us sort of spend umpteen amounts of time with our devices on cell phones or social media, and on average, uh, people tend to spend around 5,000 hours in a year posting content, looking at content, or just scrolling through content. And as a consequence, they're generating a lot of digital traces. So we might be posting cat images or videos, or we might be posting using natural language. Especially in these times, there are a lot of stressful messages going around on Twitter. And we also have our cell phones, which have several sensors that look at our mobility, our location, our on screen usage, and a bunch of other things. So the question I'm interested in looking at is how do we gain actionable insights using all these heterogeneous data types? So again, we're looking at both health and psychology, specifically around health. We look at both mental health, things like depression, loneliness, cardiovascular health. And with psychology, we look at cross-cultural differences, how do emotions differ across different cultural contexts, and how can we build computational models to understand these questions better. So I work closely with the School of Medicine, the Center for Digital Health, and the Penn Positive Psychology Center in addressing these problems. So broadly, we are interested in two different things. Number one is using big data to measure well-being. And number two is after we get these measurements, we'd want to validate these measurements and then also develop necessary interventions to actually improve well-being. So there are a ton of different challenges in this area. For example, a lot of studies look at very small populations because it's really difficult to get data with actual ground truth. So studies often look at a specific university or a specific student population, but when we're looking at scaling these observations, we need to build models which are actually generalizable across multiple demographics and across multiple cultural contexts. And number two, a lot of work is going into developing feature processing pipelines. So you have these heterogeneous data streams coming in, often at a very high frequency. How do we build pipelines which can help in building reproducible models? And number three, especially important in working in medicine, is how do we interpret these models? How interpretable are these models? Especially when we use deep learning methods to assess people's health or people's health outcomes. How confident are we in our estimates, and how interpretable are the models actually are? So I'll go into a specific study that we've been doing across the last 8 months, where we're trying to assess the psychological impact of COVID-19. So we started with so there are a number of ways you could measure this, how are people feeling, right? So number one is you could just have a massive survey and just ask people, how are they feeling? But then this is very resource intensive. It'll cost a lot of money to poll people, and it's also very time taking. You can't really get a real time pulse of different communities. So we sort of turn to social media language, specifically Twitter, and we use models that are built on small individual data sets, and then we apply domain adaptation, and then use those models across the US. So models can be built on platforms like Facebook or Twitter, which have very different language distributions. Now your target data set is Twitter, which has its own constraints, much different from Facebook. So how do you scale and how do you adapt these models across multiple platforms? So we've sort of created this dashboard, which updates every day, which looks at how mental health metrics like anxiety, loneliness is changing every day, in every county across the US, and what symptoms are people talking about on Twitter across the US. And this was especially interesting in the initial stage of the pandemic, where the Center for Disease Control actually released only 3 different symptoms that are associated with COVID, whereas people were actually reporting that they were having lack of smell, lack of taste, and they were also they were also observing skin lesions and so on, much before CDC actually updated their official symptom list. So there's a massive wealth of data that can be actually gleaned from user-generated content, and we sort of publish in slightly interdisciplinary venues, both in medicine and also in computational social science. And some of our metrics are also being used by the state departments, Washington State, Colorado State, and also Pennsylvania, in understanding how Twitter or social media can be used to track people's well-being. And at times, we also get covered by popular press like Atlantic and NPR, uh, looking at how our research can actually be used in policies. So this is a collaboration with multiple folks within Penn. Lai Langer, he's a professor in computer science. Rena Merchant, she's in the School of Medicine. David Dash, he's at Wharton. Russell Ramsey, he's in psychiatry. And I also work with the larger well-being consortium, which is across Stony Brook, Stanford, and National University of Singapore. So it's really a interesting collaboration of computer scientists, psychologists, psychiatrists, and communication scientists. So yeah, that's a really brief overview of what we're trying to do in this space of measuring well-being using data. And feel free to hit me up with any questions or any suggestions. Okay.